Oh, kind of is good enough. So, I want to talk about the law of cosines. Alright? Yes? Okay, so the deal with this thing is this is a tool for getting a third side. Right? You have a triangle, you know two of the sides, and maybe a little extra, and you want to get a third side. I want you guys to remind me of another tool you have for getting a third side. Nice! So when you look at this thing, you should think about the Pythagorean theorem. There's a good reason for that. This thing looks a lot like the Pythagorean theorem. Cool? Yes? All right, let me draw a picture so we can see that what we're talking about, getting this third side. Here's some triangle. Cool? No right angles means my usual trig thoughts do not apply. Yes? Okay. I'm going to arbitrarily label some stuff and say I know it. So I'm going to say I know this angle over here, theta, and a couple of the sides. So I'm going to think to myself, I know A and B. You guys cool with that? Yeah. Obviously, the side I'm going to get out of this is going to be what? C. Yeah. I'm going to learn about C here. Really, I'm going to develop a relationship between A, B, and C here. But the kind of impetus for this is I want to know about C. Okay? You guys good with this? Yeah. Okay. So let me make this into a situation I know about. How am I going to make this situation with no right angles into a situation I know about? No, because that's what I'm trying to get. Make it into a triangle? Yeah. I need to make a right angle somewhere, right? Okay, so let me cut this sucker. So I'm going to cut this thing right here. Right angle, right? Everybody good with this cut? This is just totally arbitrary cut, right? Okay, now I think my B label is confusing, right? You guys see that? So I'm going to take B and I'm going to relabel this whole thing here is B, right? That whole distance. Everybody good with that relabel? Okay, now I want you to tell me about this length and this length. You want to call those something?
B1, B2.
Let's call that one B1 and this one B2. And how about this vertical thing?
Call it that.
I'm going to call it D, I guess. Whatever, you guys can pick variables. Okay, so I called it D. Now what? I think I know some things. If I know A and I know theta, I think I can figure out what D and B1 are. You guys see that? This is back to solving right triangles, right? Like if I cover this part up, I've got a right triangle. And last time we practiced was solving right triangles, yes?
Yes.
Okay, so tell me how to solve that. Assuming I know A and theta, how do I get D?
That's a super good idea.
Okay, so now I'm back in right triangle land, yes? Okay, so what relationship do I have between theta, A, and D? That was good. Say that with more confidence, whoever said that.
Sine.
Thanks, Ethan. So sine, right, is some kind of theta, A, and D thing. What kind of A and D and theta thing? Okay, so if I write down sine of theta, right, what's that going to be?
D over A.
It's going to be D over A. Now I'm pretending I know A, right? I want to find D. Lay your hands on that for me. So
Sine theta equals A
A sine theta, and you multiply both sides by A, right?
Yeah.
Okay, see that? Okay. How about B1 and A? How are those related? Cosine. Let's see. So if I do cosine of theta, I'll get what? E1 over A. Yeah? Okay. So I multiply by A, and I get what? Cool. And A cosine theta is what? B1. Okay, so I'm just going to drop those labels off my picture, right? I'm going to say, okay, I know what D is. D is A sine theta. Okay, I know what B is, or B1 is. B1 is A cosine theta. Okay, you guys ready for the trivia part?
B minus B1 is B2.
Dude, yes, that is so good. You guys all see that? This length, B2, right? That's this whole length minus the short bit that I just found. You guys see that? So I can nix B2 out of my picture and replace it with B minus A cosine theta. You guys see that? All right, ready for the crazy, crazy step? No. Okay, I'll let you take a deep breath here. Look at this triangle. Do I know this part now, if I know A, B, and theta? Yeah? I got that. Do I know this part?
Yeah.
Yeah? How do I find C if I know these two things? Dude! Good idea! Okay, so here I'm doing the Pythagorean theorem to what, the left-hand triangle? Okay, so how do you write that? What's your hypotenuse on the left-hand triangle? Oh, this one's not going to work quite as well. That'll work. Right, so if I do the Pythagorean theorem to this triangle here, what's the hypotenuse? C. So C squared is, oh, that's nice, right? It's in the hypotenuse place.
A sine theta squared plus.
Ah, okay. So I need this side. So I got A sine theta all squared plus B minus A cosine theta, all that jazz squared. Okay, now at this point you have to be really careful with your algebra. Right? Yeah. There's all sorts of letters flying around up in here. So I think, see, this is a number times another number, right? I'm squaring the whole thing. So how can I simplify that? Or re-express that, maybe? How about A squared sine squared theta? Right, if I'm squaring two numbers multiplied together, that's like AB squared, right? That's A squared times B squared. Right? I squared the first number and I squared the second number. Okay, that was good. That was a nice warm up. This next part's going to be wild. So, oh yeah, in fact you have to foil it, right? Okay, so off in the margin I better foil a bit. So I've got B minus A cosine theta times B minus A cosine theta.
So B squared minus.
Okay, so good thing that I'm adding this so I don't have to distribute any kind of weirdness. I think I got B squared Right, that's the firsts.
Minus.
What's your outsides?
Minus BA cosine.
Minus BA cosine theta. Right, that's this times this. And your insides? Same thing. Minus BA cosine theta. And your lasts?
Is the cosine squared.
Plus, right? So I got plus from a minus times a minus. And then how many a's have I got? 2. So I got an a squared. And how many cosine thetas are there?
2.
Also 2. So I got cosine squared theta. Woof, right?
Well,
Everybody scared?
so 2a squared cosine squared.
Okay, hang on.
So,
Let's see. So I got c squared, right? And right now, I'm rolling with, there's a b squared, right? That's pretty easy. So I'm going to write that one down first because it's easy. Then what else is there?
Minus 2b.
Okay, I got minus 2ab cosine theta. Did I lose something? BA, AB. Does it matter?
no.
Probably. Maybe. Maybe not. What are they? What are A and B?
Numbers.
Numbers, right? So is it okay for me to multiply two numbers in either order?
Yeah.
Okay. So I'm good with that. All right, and then what else have I got here? So far I've accounted for this piece, and that piece. What else you got?
Plus 2a squared sine squared.
Ooh.
Plus a squared cosine squared.
So I think I got plus a squared cosine squared theta
Yeah.
plus a squared sine squared theta.
Oh, right.
What feels a little bit funny about
The
that?
last part.
Yeah.
Isn't it equal 1 somehow or something?
Ooh.
Like, can't you, like, combine them?
Can you?
Isn't there something
No.
new there?
What's the thing?
Cosine
I don't
and
know.
sine, you can't combine them.
Say that again, Zach.
Cosine and sine, you can't combine them. Right.
Yeah.
Combine them.
So they're not like terms, right?
Yeah.
So I can't say there's two of these. But some of you are feeling a little funny about something else, right? What's the thing you're feeling a little funny about?
Sine squared plus cosine squared is 1.
Okay, so you're remembering this thing. You're looking at this last bit, right? This stuff in here. And you're thinking to yourself, sine squared plus cosine squared is 1, right? Maybe of theta in this case,
Yeah.
right? Is that what I have or not?
No. You got stuff.
I want it to be what I have. How do you fix it?
Divide by a squared.
Yeah, so divide by a squared would be a little bit wobbly. But I think I can factor one out, which is almost the same thing, right? You guys see that? So I'm going to regroup this stuff in orange. So let me see. I think I've got, so far, c squared is b squared minus 2ab cosine theta plus a squared times, what do you got here? After you factor an a squared out, what are you left with?
Just cosine squared theta plus sine.
Cosine squared theta plus sine squared theta, which is
1.
1.
Which is just a squared.
So what's 1 times a squared?
A squared.
A squared. So I could probably drop that whole bit, right?
Yeah.
Okay, so I think, all told, with just a little bit of rearranging here, what I have ended up with is, punchline, drum roll, whatever, c squared is what?
Minus 2ab cosine theta plus.
Okay, I'm going to arrange in alphabetical order, just because. So what are the a's? How many, what's the a squared thing? So there's an a squared plus
B squared.
b squared
Minus
minus
2ab.
2ab
Cosine theta.
cosine of theta. Whoa, that looks a lot like the Pythagorean theorem, doesn't it?
Just minus.
This thing here is the law of cosines. Okay, that's your punchline. You need to be a little careful with this, just like the Pythagorean theorem. What is the thing I need to be careful with? Good. I need to be careful when I'm using this for plus and minuses, right? Because they're squared everything. You aren't going to have to FOIL this out, right? That was just me trying to get this thing. So now I've got this. You've all seen how this went. There's a video of how this went. So you all are free to use this version of the cosine tool, law of cosine tool. Cool. Just like you can use the Pythagorean theorem without drawing a little picture every time. But what else do you need to be careful of?
You gotta use the angle opposite C.
Yeah, so this is one of these if-then statements, right? So the whole law of cosines is if you have a triangle, right? And this, all the colored stuff was stuff I added to it afterwards, right? If you have a triangle set up like this, where the angle theta is opposite of the side C, then you can run this thing. You guys see that? So you got to make sure you're set up in the if the right way before you try to run the thing. Cool? Questions, things? You guys all okay with this as a new tool?
So this is how you find a side in a triangle that doesn't have a right angle per se?
Exactly. So if I have a triangle, right, where I know an angle and two of the sides, I can get the third side using this. With a little bit more subtlety, we'll also be able to take three angles and turn it in, or three sides and turn it into an angle.
Gotcha.
You guys see that? That'll take a little bit more trickery that we're not going to do today, but we'll do next time. Cool? Questions on that? You guys want to see an example, right?